Welcome to AeroMandira YouTube channel where the knowledge that takes flight. This channel is your guide to the world of aviation software and safety standards. From DO178B certification to avionics lifecycle process, we simplify complex topics into clear and engaging videos. Whether you are an engineer, student, or an aviation enthusiast, AeroMandira helps you understand how aircraft systems are built, tested, and certified to keep skies safe. Today, we are diving into a topic that's at the very heart of aviation safety, that is, software. Every modern aircraft, whether it's a commercial air jet or a business plane, runs on thousands of lines of code. From navigation to autopilot, flight management to engine control, software is everywhere. But here's the question: how do we know this software is safe? And how can we trust this software with the lives in the sky? So the answer lies in an international standard called DO178B, which is a rule book that guides how airborne software is built, tested, and verified. In this video, we will break it down in simple terms that what DO178B is, why it matters, how it classifies the risk levels, and how it shaped modern aviation standards. In today's video, we are going to talk about DO178B, the international guideline that ensures the software in aircraft is safe, reliable, and ready for certification. So, this is the foundation of aerospace software development, and it's something every engineer in this field should understand. So, what is DO178B? So DO178B, also called as Software Considerations in Airborne Systems and Equipment Certification, is a standard created by RTCA. So it doesn't tell you how to write your code. Instead, it defines what processes, activities, and evidence are needed to prove that your software is safe enough to fly. So it is used worldwide. FAA in US, EASA in Europe, and other certification authorities all rely on it. So in simple terms, you can see this as a safety rule book for developing the software, for all the software which goes into an aircraft. So why D178B is important? So in aviation, we cannot afford mistakes. A small bug which you feel might be harmless could be catastrophic in an aircraft. So imagine autopilot miscalculating the altitude or a warning system failing at the wrong time. So the consequences could be a life threatening. So that is why before any aircraft system is approved to fly, developers must prove with documentation and testing that meets that it meets the DO178B guidelines. So the process builds trust and confidence for pilots, passengers, airlines, and regulators. So, so one of the most ideas in DO178B is software levels. Not all software has the same impact on safety. So DO178B defines 5 levels. Number one, level A, which is classified as catastrophic. So the failures can cause loss of aircraft, for example, flight control systems. So let's imagine if any of the flight controls fails, and if there is any failure, so that might lead to a catastrophic event where you cannot control your aircraft and you might end up in a crash which can take away the lives of the passengers, crew members, it could be anyone. So it could end up in a catastrophic event. So, so that is why we call that as a level catastrophic. And level B, which is classified as hazardous. So these failures could cause serious injuries and severe workload on the pilots, for example, warning systems. Level C is classified as major. So the failures could be significant but not catastrophic. For example, navigation or communication. Level D, minor. These failures can have a small effect on operations, for example, cabin lighting, but it cannot cause any threatening to the aircraft. So level E has no effect on the safety, for example, entertainment systems. So the higher the level, the more rigorous the development and testing requirements is. Moving on, DO-178B follows a life cycle approach. Each stage builds on the previous one. So the requirements are the very initial phase in the life cycle where we define what the software should do, and in the design phase we break down requirements into detailed design elements, and in the code phase we implement the design in actual software. Verification, this is the heart of D178B, where we we verify the software in three types of verification methods: reviews, analysis, and testing, to make sure the code does exactly what it is supposed to do. Certification, where all of this evidence is presented to authorities like FAA or EASA, who then approve the system for use. So this structured approach ensures that from the first requirement to the final test, safety is always the priority. So that's a quick introduction to D178B, the rulebook that guides the development of safe airborne software. So in the next video, we will talk about DO178C, which is the updated version, and we'll explore how it builds upon DO178B. So if you found this useful, don't forget to like, comment, share, and subscribe to AeroMandira YouTube channel. Thank you all for watching once again.